Hi and welcome back. So here's another question about alkanes. Including cycloalkanes. So draw the structures of saturated hydrocarbons which meet the following two criteria. Number one, it must have the formula C7H14. And number two, it has only one primary carbon atom. Only one primary carbon. So C7H14, that means it's a CnH2n. Okay, so what that means is that this molecule either has some unsaturation or it has a ring. And because it's saturated hydrocarbon, it's not an alkane or anything, so it must have a ring. Otherwise, saturated hydrocarbons have formulas like CnH2n plus 2. Okay? So, and then now here's our formula. So we know that it's a compound that has one ring. Okay, and then it has only one primary carbon atom. So that means is that the ring has got one and only one substituent. Okay, so let's see. Say this one, this is the ring. We don't know how many carbons. We'll figure out in a moment. But this is the ring, and it's got at least one substituent. That way, that's the only way for it to have one primary carbon atom. And it's not going to be a branched substituent like that, or like that. It's not going to be branched. Eliminate that one. It's got to be a linear one. That or just a methyl group. That's the way to ensure that it's got only one primary carbon atom, which is on the end, right? Otherwise, if we have a branched substituent, you're gonna always have more than one primary carbon. So it's not a branch. It's got 3 primary carbons. So yeah, so it's got one ring and one substituent, and that substituent is going to be linear or a methyl group, right? So with that information, let's see. One possible structure would be it can't be a 7-member ring. It's not going to be a 7-member ring because that uses up all the carbons, and we don't have any carbon to be used as the substituent. So the largest ring it could be is 6-member ring, a cyclohexane structure with the substituent being a methyl group. Okay, we can draw out the methyl group like that. That's one structure that we got, and then we can work our way down and decrease the size of the ring by 1 carbon at a time, right? About 5, because that's the only possibility for 6-member ring based structure that meet both of these criteria. So the next possibility would be based on a 5-membered ring and a methyl group, a ethyl group as the substituent, right? It could only be one ethyl group as the substituent rather than 2 methyl groups, because that way you would have 2 primary carbons. This is the only way to ensure you got 1 primary carbon in the structure of the 5-member ring of the cyclopentane based structure. So that's it for 5-member ring structures. That's the only possibility. And the next one will be a 4-membered ring having a 3-carbon substituent. 3-carbon substituent. Again, that's got to be one single substituent. A linear substituent with all 3 carbons like that. Again, that's the only way to have just one primary carbon atom, because these are all secondary carbons. This one at the end is the only primary carbon atom in the structure. And again, that's the only possibility for 4-member ring, cyclobutane based structure. And the next one would be a 3-member ring with 4 carbons as the substituent. Again, that 4 carbons will be existing in just one substituent. One substituent to make sure that we have only one carbon. That's the primary carbon. That's the one at the end, right? If we have more than one substituent, I'm sorry. If there are more than one substituent on the ring, that would give you more than one primary carbon atom, because each substituent will have at least one primary carbon. Is that right? Each substituent has at least one primary carbon. That's why if we want to have only one primary carbon, we're going to have only one substituent. No more substituents. So that's it. 3-member ring is the smallest ring that we can have, right? There's no such thing as a 2-member ring or anything. So I would say those 4 structures are all we can come up with that meet both these criteria. Okay? Very nice. Thank you very much. Any questions, do not hesitate to email me or call me, or you can subscribe to my channel or visit MacroLearning.com. Thank you so much. See you next time.